All right, today in algebra, we are doing section 4.2, the properties of inequality. Okay, so we are talking about inequalities, this whole chapter. We started on it yesterday. So solving inequalities is similar to solving equations. Remember how we balance the equation. If we have x plus 2 equals 4, we subtract 2 on both sides of the equation. Remember, the sides is where the equality symbol is. So on the left and on the right. Okay, and then, so then plus 2 and minus 2 cancel. We're left with x. 4 minus 2 is 2, and then we bring down our symbol. So x is equal to 2. It's very similar to solving an inequality, or solving an inequality is very similar to that. Okay, so we have first up the addition property of an inequality. So if a, b, and c are real numbers or expressions, so that just means like they're 1, they're 2, they're -5, they're 3/5, okay? But they're real numbers, they're not imaginary. Okay, so that a is less than b. Then if we take a and add c, that's going to stay less than when we take b and add c to it. So let's put some real numbers there. Let's say a is 1 and b is 3, okay? So and then we do this, we're going to have 1 plus, let's say c is 2. 1 plus 2 is less than, b was 3, then 3 plus 2. Well, 1 plus 2 is 3, and 3 is still less than 3 plus 2, 5. This is still true, right? This is just a numerical example of what this is talking about, okay? Because a was 1 and b was 3, and 1 is less than 3. So when we add c, another value, it's going to stay the same. The other thing is this is true for all 5 inequality symbols. It doesn't matter if it's less than, greater than, less than or equal to, greater than or equal to, or not equal. Okay, it doesn't matter what the symbol is, it's true for all of those. So let's look at example 1. It says solve and graph, so 2 parts. The solution set to each of the following. The first one I have done for you, so we can just talk about it first. So we start with x plus 7 is less than 8. Okay, remember our inequality symbol is like where we're splitting, or each side of our inequality. The symbol is the 2 parts where we're adding and subtracting. So my line's a little off. It should actually come over here. So since it's x plus 7, we do the inverse. We subtract 7 on both sides. So plus 7 and minus 7 cancel and leaves us with x. 8 minus 7 leaves us with 1. And then we bring down our inequality symbol. So x is less than 1. Again, this should, like the way I drew my line, that should look more like x is less than 1, so you can see it. But I wasn't really thinking about that or planning on it when I drew it. And then graphing it. So to graph it, I'll give you a number line in each of these. It's less than, so it's an open circle, okay, because it's not less than or equal to. It has to have the equal to be a closed-in circle. And less than, so we put our arrow to the left, to the numbers that are less than. So open circle and pointing to the less than side. All right, let's do the next one together. All right, so I'm going to go ahead and split this kind of down, our inequality symbol. We have x minus 5, so we need to do the inverse. We're going to add 5 to both sides. So x minus 5 plus 5 cancels, leaves me with x is not equal. I'm going to bring down my symbol. 3 plus 5 is 8. All right, awesome. So I have x is not equal to 8. All right, so for this one, it's kind of a fun one to graph. So x is everything but 8. So we're going to put an open circle at 8, and x goes both, and the line goes both ways because it's greater than and less than. It's just not 8. So that's kind of a trippy one. Okay, and our next one. So we have negative 0.6, or 6/10, is less than or equal to x minus 0.4. So again, I'm going to draw kind of my line at my inequality symbol. And this time x is on the right side, and we have x minus 0.4, so we're going to add it. Plus 0.4 on both sides of the inequality. Then we have, so negative 0.6 plus 0.4 equals negative 0.2. We're going to bring down our less than and equal to symbol. And x minus 0.4 plus 0.4, these cancel because they equal 0. So it's just going to leave us with x. So negative 0.2 is less than or equal to x. All right, so this time it's the less than or equal to. So that gives us a closed circle. So negative 0.2 closed. And it says that number is less than x. Okay, so a lot of times people get confused when the number comes first. In each of these other examples, it was x is less than or is less than 1. X is not equal to 8. This one people can get confused by because the x is on the right side. You can rewrite this the other way. It's like reading it, okay? Read it from the right and then rewrite it. Okay, what I mean by that is if I read it from this way, I'm going to say x is greater than or equal to negative 0.2. Okay, that often, because we wrote it, we flipped everything over. It's like we took all of this and we just flipped it. And we flipped the symbol too. So x is actually greater than or equal to negative 0.2. So that means my line is going to the right, to the greater than sign. Okay, so it's helpful if your variable is on the left when it comes to graphing, if you have to graph it. All right, perfect. Let's move on down to the multiplication property of inequality. Okay, so the multiplication property of inequality says if a, b, and c are real numbers or expressions such that, okay, again, we have a is less than b, and we have two different situations here. Okay, so the first one, when c is greater than 0 or it's a positive number, then ac is less than bc. However, if c is less than 0 or a negative number, then AC is greater than BC. Again, we're going to get the same results for any symbol we use, greater than, less than or equal to, or greater than or equal to. But what this is saying is that we have to reverse the inequality symbol. Okay, when we multiply or divide by a negative number, we flip that sign to make the statement true. Otherwise, the statement is false. Okay, so if if we're dividing by a positive number, no big deal. These stay, right? It still stays less than. If it's a negative number that we're multiplying or dividing by, we have to flip the sign or the symbol. So again, let's actually try that. Example 2. Solve and graph the solution set. All right, so if I cut my inequality in half, the first step here is to divide, because I have negative 3 times x is less than negative 9. So I'm going to divide by a negative 3. Because it's a negative, right, I'm dividing by, that fraction bar means negative, but because it's a negative, I need to flip that sign, which I did not do, right? I divided by a negative, but I did not flip the sign. So please make that correction right now. Okay, flip the sign. So x is greater than 3. I graphed it correctly, but I didn't flip it when my answer. Okay. So in this case, I don't get to just bring the sign down because I divided by a negative. To graph it though, it's open circle, because it's just a greater than sign, and x is greater than, so we're graphing to the right. Always make sure your line has an arrow on it. All right, so let's look at B. Okay, so let me draw my line to separate my inequality. And so I have x over 12, which is division, x divided by 12. So I'm going to multiply by 12 on both sides. On the left, division and multiplication cancel. So I have x. I multiplied by a positive number, so I can just bring my symbol down. And over here, it's negative 4 times 12. So my answer is negative 48. But the negative was already there. Okay, I didn't multiply by a negative 12. I did that. That was positive. So I don't have to change anything. Okay, so this time x is greater than negative 48. So it's an open circle again. 48 is the one in the middle here. So an open circle at 48, and x is greater than, so it's going to the right again. All right, last one. Let me divide it in half here. Got that a little long. All right, so here I have negative 5 halves x is greater than or equal to 25. All right, well, we can multiply by the reciprocal. Remember, when we have a fraction, we multiply by the reciprocal. So I'm going to multiply by the reciprocal of that, which is negative, because I got to get rid of the negative. And this is 5 halves, so I'm going to multiply by negative 2/5. The reciprocal is the flip of that. So we're going to multiply by negative 2/5 on both sides. Okay, so I multiplied by a negative. I'm going to go ahead and flip my sign right now so I don't forget. As soon as I do it, I'm going to flip my sign. So my negatives cancel, and I have x is less than or equal to 25 times negative 2/5. So I know my answer is going to be negative because it's a positive times a negative. But, so this is 25 over 1 times 2 over 5. Okay, I'm going to do some canceling because I don't have a calculator up here. So 5 times 2 is 10. So x is less than or equal to negative 10. All right, so this is what I'm graphing. It's less than or equal to, so it's going to be a solid filled in circle at negative 10. So fill that in. And x is less than, so it's pointing to the left. Again, that only works if your variable is on the left. If you're reading it, x is less than. All right. So this is huge. Reverse. Okay, this is the one rule you have to remember that's different. You have to reverse your symbol if you're multiplying or dividing by a negative number. Okay, so let's flip over to the back. We have one more example. Okay, so this one is, again, inequalities can be used for real-world examples. Like they can model and solve like questions from everyday life. So I've got kind of our setup here. How much money must be invested at 7% simple interest to produce a yearly income of at least $875? Okay. So this goes back to that formula, principal times rate times time equals interest. So let's go through here and set it up. So how much money? That says how much money. That's the thing we don't know. So that's where we're going to put our variable. Okay, that's going to be our variable. And that also says down here, P equals the amount invested. So we're going to put P in there. At 7% simple interest. Well, is that our rate, our time, or our interest? That's our rate. Okay, so it's going to be 0.07. Don't forget the 0 in front of your 7. And we want to produce a yearly income. So for our time would be, yes, 1 year. of at least. Notice this is like squiggly underlined. At least is important because that's a symbol. At least means it has to be equal to that, or it has to be more, which means it has to be greater than or equal to. Okay, at least means it's equal or more, so that's equivalent to a greater than or equal sign. So it's greater than or equal to $875. So is this the number I'm going to put in my interest? No, no, it's not. Because remember, this is a formula. My principal times my rate times the time is going to give me a formula, like an expression to put in here. So this is equal to 0.07p. And then this expression, we're saying this has to be greater than or equal to 875. So we're going to say, well, 0.07p is greater than or equal to 875. And then we need to solve it. So to solve it, what are we going to do? Let me divide my... Excellent. We're going to divide by 0.07 on both sides. And then we're going to get our principal. We divided by a positive number, so we just bring our symbol down. Bring that inequality symbol down. And what is 875 divided by 0.07? Hopefully you brought your calculators today. Okay, you should have gotten 12,500, which I put up here in this box, right? Like if you do it correctly, you should get that P is greater than or equal to $12,500. And we can add, since we're done, we can write out a statement that says that. So when it says how much money must be invested, well, $12,500 or more, just like we said here, or more, must be invested. That is your final statement. But, you know, you're like working on setting up the inequality to solve that and being able to solve it. Because here's the thing, solving equations will be what you do in math the rest of your math career. So getting down, continuing to improve on solving your equations. Yes, I know this is a simple two-step equation, but they're going to get more complex. And they're already more complex because we're using inequalities versus an equality or an equation. So continuing to work on that, as well as we're continuing to work on these real life, everyday problem solving questions. There'll be a few of those in your homework tonight. So also don't forget, test corrections are due. You need to bring them in because there's only, I don't know, 12 or 13 days left in the quarter for you to get your grades raised up if you need to from test corrections. And you need that information and to continue to improve on it and work on it and get better at it so you can continue to do the math. All right, I will see you tomorrow.